This video is on quadratic basics. This is a video to explain the basics of quadratics, of just understanding the forms that we're going to look at and the coordinates that are most important when we're dealing with quadratics, especially without the use of a calculator. The first form we're going to look at is factored/intercept form. This is not the same thing as slope-intercept form. This does not give you your y-intercept. Please be careful about that. Factored form means that we took it from standard form and we factored it into factors, into multiplication. Intercept form is because it actually gives you your x-intercepts of your equation. So factored/intercept form gives the x-intercepts, not the y-intercepts. Another word that we might see for x-intercepts will be the solutions. When we are solving, you'll see roots or you'll see zeros. When it asks for x-intercepts, if it asks for zeros, it's also asking for when is the y value 0, so what is the x-intercept. The root is when is it crossing the x-axis. Solution is what is the x value that solves this problem. So the form that we'll see here is f of x, because that really stands for y. Please remember f of x is another way of saying it's a function of x, is equal to a times x minus m times x minus n. This is factored form because we have a factor times a factor times a coefficient. So in this case, the x-intercepts will actually be given from the factors. Our x-intercepts would be m, 0 and n, 0. You might see it as x minus p, x minus q. It's really just saying that it's the x-intercepts. So we're going to factor a standard form to get it into this method, into this form, to get the x-intercepts. Standard form is when you have generally a quadratic trinomial, when there are no parentheses, it's all polynomials, all adding, subtracting. Standard form actually does give you the y-intercept. Standard form gives you your y-intercept. So a linear function is generally the function that, when you hear intercept, it's the y-intercept. But standard form will always give your y-intercept for every other type of function. So the way the standard form looks is f of x equals ax squared plus bx plus c. There are no parentheses. There are all of these are polynomials. There is no denominator of a variable. All of the exponents are whole numbers. This is in standard form because we have distributed everything out. So your y-intercept actually comes from your constant, just like when it was in slope-intercept form. So our y-intercept would be our 0, whatever our constant is, which in this case will be c. So if we're looking at these, we want to be able to see it on a graph as well. On a graph, we have the x and y axis. So this is our x and this is our y. We're just going to count by 1. There are some important pieces on quadratics that are the basics that we need to know. First, we have our x-intercepts, where the graph crosses the x-axis. We have a coordinate here and a coordinate here. This is your x-intercept. You have 2 of them on this one. This again is also called solution, roots, or zeros. If you see any of those words, they all mean the same thing. This would be m, 0. You have another x-intercept, which comes from your factored form, which is our n, 0. So again, these are where it crosses the x-axis. You also will have your y-intercept, which comes from your standard form, where it crosses the y-axis. This is your y-intercept, which would be our 0, c. Now, because you have a quadratic, you have this spot down here where it was originally decreasing, and then it turns and it starts increasing. This is called the vertex. This is an x, y coordinate. All of these are x, y coordinates, but these are very special. X-intercepts have a y value of 0. X-intercept has a x value of 0. The vertex will only have a 0 if it hits those spaces. So a vertex is not going to have a 0 automatically. But your vertex is where it stops decreasing and starts increasing, or stops increasing and starts decreasing. It's when it changes directions. Now the thing about the vertex and a quadratic is that your quadratic is actually symmetrical. You can flip this quadratic, you can fold it in half along what's called the axis of symmetry, and this part of the graph will fit perfectly on this part of the graph. So what it's called is the axis of symmetry. It's that it is a vertical line that goes through the vertex. It is a vertical line, so it's the x value. It's an x equals. This is the axis of symmetry. This is where you would actually fold along the graph so that the left side will fit perfectly on the right side. We can also call this the AOS because it's just axis of symmetry. And since it's a vertical line, it's an x equals because that's the only type of equation that you cannot graph in a calculator. X equals, and it's going to be actually the x value of your vertex. You don't even have to try and find it on your own. It is the x of the vertex. So in this case, it would be x equals 1 because our vertex is at 1, negative 4. So our axis of symmetry is x equals 1. Now, because we have symmetry, we can see that the x-intercepts, I'm going to draw this out real quick, the x-intercepts are 1, 2 spaces away from the axis of symmetry, 1, 2 spaces away. So you can see that these are symmetrical away from it. Well, we can do the same thing with the y-intercept. The y-intercept is 1 space away, so if we go another space away, we have the mirror of the y-intercept, which will help us to be able to graph a nice, clean graph, because you want to have as many coordinates as possible. This is the mirror of the y-intercept. We want, so that we can graph this as nicely as possible, we always want to try to get 5 points to make the graph accurate. So the 5 points are your 2 x-intercepts, your vertex, your y-intercept, and your mirror of the y-intercept. If there is only one x-intercept because it bounces, that's okay. That just means that we'll need to get another coordinate so that we can have 5 to make it as accurate as possible. So we want to be able to connect them into this U shape. This shape is called a parabola. A parabola. A quadratic is a parabola. It's not a parabola, parabola. So let's talk about the a value that is on both of these functions. It is the coefficient in intercept form. It is the coefficient in standard form. The a value tells you a lot of information. If the a value is positive, it tells us that this graph opens up. And this graph, since it was opening up, meaning that the arrows are pointing up, that the a value is going to be positive. It means that it has a minimum value. Because our vertex is at the lowest point on the graph, it tells us that we have a minimum value. If your a value is negative, that means that the graph opens down. because the arrows will be pointing towards the negative location. That means that our vertex would be at the top of the graph, so we would have a maximum value. So if it opens up, we're going to have a minimum. We have the lowest point on the graph because everything else is above it. If it opens down, that means we're going to have a maximum because everything is going further down forever. Now, if, with positive and negative, we know it opens up or down. So what if the A value is just bigger than 1? So these are both talking about positives. It can either be bigger than 1 or it can be between 0 and 1. So if we're looking at just the number itself, this will actually tell us how fast the y will change, because the x's are going to increase, but the y's will change either increasingly or decreasingly. So the y's will change faster or slower. So if our A is bigger than 1, the change in y is actually faster. If it's by a 1, it's just going to change at a normal, increasing rate, because it's just going to keep squaring things. But if it's bigger than 1, like 2 or 3 or 4, it's going to change even faster, so it becomes a vertical stretch. Because it's changing even faster, it becomes more stretched out because it's going faster. So if A is smaller than 1 but still bigger than 0, so still positive, then our change in y is actually going to be slower. So it won't change as fast. It'll actually be opened up more because our y values are not going as fast. This is called a vertical compress. Because it's actually going slower. It's almost like you're pressing down on a soda can to compress it. Then we want to talk about the domain and range. The domain of a quadratic will continue to go left and right forever. So the domain we know are the x values, and we read them from left to right. Now on the left side of our graph, we have an arrow. That means we do not have a minimum x value to our left. And on the right-hand side, it does not stop on the right-hand side, so we do not have a maximum x value on the right. That means that our domain will actually keep going forever. That means that our domain is all real numbers. We can write that as x is an element of, so it's like a fancy e, of all real numbers. We could say it as a symbol, or we can say x equals all real numbers, because every x value your graph will cross through. Your range are your y values, which we read from bottom to top, because we need the minimum y value to the maximum y value. Now, if there is a positive or negative, if it opens up or down, this changes. So if the graph opens up, just like what we have up here, if it opens up, then we're going to have a minimum y value, and everything above it is going to hit. So that's the y value of your vertex. If it opens up, we're going to write that our range is y is greater than or equal to, and then whatever the y value of the vertex is, because that is your minimum value. So if it opens down, we'll say the opposite. It's going to be y is less than or equal to, because it's going in the opposite direction, and it's still the y value of the vertex, because your vertex is your lowest point or the highest point on the graph, so that helps us find that y value for our range.